This is the video for Unit 6, Lesson 14, where we'll be able to solve multi-step percent problems in context. So let's take a look at think about it. It says, Sophia and her friends are eating lunch in the city. The bill is $45 before tax. The girls want to leave a 15% tip on the total bill with tax. How much will the total bill be, including tax and tip, if tax is 8%? Create a plan and solve showing all your work. Okay, so let's see what we know. We know that the bill is $45 before tax. We also know that the girls want to leave a tip of 15%, and that's going to be on the bill with tax. Then it says that the tax is 8%, so let's also circle that. Tax is 8%. So let's create a plan for this. First step. Again, we know that the bill is $45 before tax, but they want to leave a tip on the bill with tax. So we need to find the bill with tax. We're going to calculate that. And then after we do that, we can then put that 15% tip on there. So find the taxed bill with tip. So first thing I'm going to do, like we always do, is draw my double number line. This. And we know the two units we're working with are money here and percents. But I'll draw my $0. $0 and 0%. Then we also know, since it's percent, we're dealing with 100%. This is our whole. And how much are we adding on to 100%? It says find the bill with tax. Tax is 8%. So 8% is going to be over here at 108%. That represents the bill with tax. We don't know what that is, so that's going to be our X. And then what we do know is that $45 is going to be based on that. Or it's got to be based on $45. So now we can take that equation that we've been using just about all last week, and we can plug in our, what is this? This is our whole. This is our quantity. This is our percent. So we're going to take our quantity equals our percent. It's a decimal times our whole. Quantity equals, let's see, we're working with 108%, so I need to move this decimal again. It's going to be 1.08 times 45. And when we calculate that, we're going to get $48.60. So now that was step 1 that we just did. This is right here. That's our bill with tax. It says find the taxed bill with tip. So if I'm finding the tip, right, on the taxed bill, am I going to use this $45? No, what am I using as my whole now? I'm using the quantity that I just found. So what I'm going to do is I'm actually going to draw another double number line. I'm going to draw it over here now to represent my new whole. And a whole is really just something that our new quantity is going to be based on. So we have $0 again, we have 0%, and now our whole is 100%, which is going to be $48.60. And how much is the tip? How much are we adding on to 100%? It looks like we're adding on 15%. So when I add on 15%, I'm going to end up with 115%. So again, I'm going to take that equation. This time I'm going to use it in orange so we know our final answer is going to be represented by it. Quantity equals the percent of a decimal times the whole. And like we said, this is our new whole. This is our new quantity. And this is our new percent. So I'm just going to substitute. Quantity equals 1.15 this time times 4860. And we're going to plug it into the calculator. We get 1.15 times 48 times 4860. We get $55.89. So now that we have our final answer, right, this is what it's asking for. It says, how much will the total bill be, including tax and tip? Right. How can we solve these problems that involve multiple percent scenarios or multiple percents? And this is going to be our key point for the day. The answer to that question is going to be our key point. So let's copy this down together. What did we do? What changed? Our what? Our whole changed. So when a problem, copy this down in the key point box, when a problem involves percent scenarios, we must carefully identify the whole in order to take a percent of. Okay? When a problem involves percent scenarios, we must carefully identify the whole to take a percent of. And now that we have this key point, we can move on to the interaction with new material.